Today we are doing extrema and end behavior, a riveting topic. Give me 1 second. Get my notes. Okay. So functions on the extremes, right? End behavior, what's happening at the end of functions. So talking about extrema of functions initially, graphs of functions can have high and low points where they reach a max or min. Max and min values of a function are called extrema. First blank spot, extrema. So important you don't blow off the math language we talk about, right? Because you take SAT and it's full of math language. Remember, in here we don't have time to go over SAT practice stuff. I have to teach you Algebra 2, and there's more Algebra 2 on SAT than I can cover in the time before SAT, right? You take SAT in April, and I still have 6 weeks of Algebra 2 to teach you, and that's on SAT. Is that fair? No. Guess what? Nobody cares. So you have to go through and do that stuff on your own, and it's just the reality of it, and it's kind of crappy, but that's the way it goes. Okay? So Khan Academy, K-A-H-N, has really good SAT stuff. Tons of activities and practice and videos explaining. So I would go on there, and honestly, I would start now and do like an hour a week. And then by the time SAT rolls around, you'll be totally ready for SAT. Okay, the maximum is the highest point. Maximum is the highest point on the graph of a function. It's called the absolute maximum. So if it's an upside down parabola, there's a maximum. That's why it's absolute. If you have one that goes like this, then it has a relative max and a relative min. If it looks like this, it has two maximums, right? So that's why it goes from absolute, as in there's only one, to relative, which we're about to talk about here in a sec. Lowest point's a minimum, shockingly. Lowest point on the graph, it's also called absolute min. Absolute max, absolute min. So a relative max is like the M graph that I drew you, right? If it looks like this. So this one has two of them, right? So here's one max, here's the other. So two different ones, right? So could have, right, the one on the left's higher, but they're both still maximums. That's why they're called relative. Relative minimum is located in where no other point, yeah, it's fine. Okay, so we're going to identify some of these now. So if I'm looking at this graph on the left here, does that have an absolute or relative min or max? Absolute min, right? Because this low point right here is the minimum. There's only one of them. That's why it's absolute min. So what is that absolute min if I get the ordered pair? 0, -5. That is the absolute minimum. Okay. So what is this point called right here? Relative max. So let's just write that down. Relative max. And you don't have to write the whole word. I'm fine with relative max. You can abbreviate. Right? What is the coordinates of that relative max? -2, 8. Okay, relative min down here, right? Organized use of color is your friend. Remember, I will take points off. I will grade your notes and take points off if you're not using two colors. What is that? Relative min? The order pair is, don't be scared, 0, 4, right on the y-axis. So pretty straightforward, right? Easy. Absolute if there's only one, relative if there's, right? And even though there's just one max, it's still relative because there's a max here and a min here. So if there are two of them, whether or not mins or maxes, they're still relative. If there's only one, max or min, then it's absolute. Okay, so here's this crazy table of values. We're going to use this table and graph to estimate extrema of the function that relates to the number of hours since midnight, the number of posts being uploaded, and we're going to talk about what the extrema mean in the context of this situation. Okay, so social media posts, good times. So it's the number of hours since midnight. So what time of day are people posting a lot on social media? Right there, right? That's the most. What time of day is this? If it's 12 hours since midnight. 12 p.m. Is that true in your life? When do you think the most social media posts are? Midnight. More like middle of the night, right? You guys, how many people stay up till past midnight every night? Look how many hands are up. What time do you get up? 6? That's not enough sleep for your little brains, right?
No, I go to sleep at like 8.
Oh, you wake up in the middle of the night?
Yeah.
Yeah. Same thing used to happen to me terrible. I'd be up for like 2 hours. Sleep much better now. So I don't think this is true given a teenager's life. I think most of your posts are like probably 10 to 2 in the morning. It's probably when the most posts happen. But whatever. So what is the max? Where x equals, here actually let's write it over here. Where x equals 12, that's where the y is the highest. What are the max posts? So if it's in thousands right here, right? In thousands, and it's in hundreds. Oh, I forgot. I missed this. In hundreds of thousands. So it's 11.5, right? So if it's 11.5 and it's in hundreds of thousands, how many zeros do I add? So 1, 2, right? So then I don't need that decimal point anymore. That's unnecessarily confusing, right? So hundreds of thousands, so it's, oh, I whiffed on that. Sorry. I whiffed on the comma there. My bad. Oh, wait, did I screw it up? Should be 1,150,000. Ignore that, my bad. 1,150,000. Right, so hundreds of thousands. Like, I would never put one like that on the test because it's just, you could screw it up just because you're weird about it, right? Hundreds of thousands. So hundreds is the 150, hundreds of thousands. So you want to go to 100,000, right? It's unnecessarily confusing. So there are 1,150,000 posts at what time? At noon. Do you ever get confused whether 12 a.m. is midnight or 12 p.m. is midnight? 12 a.m. is noon, 12 p.m. is noon. It's it can be confusing, right? So you could just say noon, and then you know you got it right for sure. So where's the min? Where's the lowest min? At 4, right? For what? 4 a.m. And how many posts? Yeah. So how many are there if you go to hundreds of thousands? It's confusing. So right here, let's say that's 1.8. So that would be 4 comma 1.8. So if you had hundreds of thousands, it's 180,000. So 180,000 at 4 a.m. Okay, relative max. So what point is a relative max? So as we look at this thing here, so this was the, right, so this max, the next one down basically. At what time? 16 hours after midnight is what? 4 p.m. But we have to do the order pair as 16, right? You can't use 4 because there's already 4 on that plane. And then that value is, so they say 1.02, right? Which is, again, like it's a terrible graph. They shouldn't have done this like this. So relative max, I should find a better graph for next year. Relative max, x equals 16. And then that's the second highest point. Okay. And the relative max number of posts are 1,020,000. Okay, relative min. So that's going to be the dip right here. Right there. So what time is that? Straight down. So x equals 14. We'll just say that. It's fine. So x equals 14. And what was that value? They said 910,000 posts. So x equals 14, how do you know for sure? Because x equals 14 right there, right? 9.1, so 910,000, hundreds of thousands. In the hundred thousands place is what that means, hundreds of thousands, okay? And that's at 2 p.m., posts at 2 p.m. So I would give you like thousands on the graphs, millions on the graph, so it's easier to like figure that out because I don't want you to miss it because you don't know what hundreds of thousands is. That'd be dumb. Okay, so we got a bunch of notation kind of stuff coming up next. So you write x with an arrow like that. That means as x approaches infinity. As x approaches negative infinity, looks like this. Right, so x with the arrow and negative infinity. So if it increases without bound, that means f of x is really y, right? So don't wig out about that. So we're just going to write as f of x. They always write f of x, though, function notation. So as x approaches infinity, without bound decreases means as f of x approaches negative infinity. So if it approaches a specific value like 2, then you would write as f of x approaches 2. And we'll do examples with all that kind of stuff coming up. So as we look at this graph down here, we're looking right down here as f of x approaches infinity. So as the graph goes this way, where's y? Y is always what value? 2. Don't make that hard, right? Okay, so it's different notation than you may or may not be used to, okay? He left you hanging on the high five. Totally, I saw it. Okay, as x approaches negative infinity, so as x is going this direction, what's y doing? Same damn thing, right? 2. Okay, so here, as x goes to infinity, it's going up forever in that direction. What's y doing? Infinity, yes. Y is going up forever as well. So as x goes to negative infinity, so as x is going this way, y is going down forever, right? So negative infinity. Give me fist of 5 on your level of understanding of that concept right there, just so I can see. It gets funky, right? You'll get used to it. If you have like 1, 2, or 3 fingers up, you will get used to it. It's just a little weird. So as x goes, I love drawing these little arrows. As x goes this way, y is going down forever, right? So as x goes to infinity, what's f of x doing? Negative or positive? Negative infinity, right? It's going down forever, the y values. As x goes to the right forever, y is going down forever. As x goes negative, what's y doing? Positive infinity. You can just put infinity. You don't have to write plus infinity. I don't care. You could write it if it helps you to understand. I'm not going to take points off. Okay, how about this one? As x goes to infinity, f of x infinity as well, right? So as x is going this way, y is going up forever, right? And how about as x goes to negative infinity? Still positive, right? Still going up forever. So as x goes this way to the left, y is going up forever this way. Okay? Okay, we're almost done with notes already. It's awesome. So, what does the end behavior represent in this context? So we're talking about a drone. What's happening in the function? Let's just talk about what's happening. What's happening right here? Where's the drone? Where's the drone? Where's the drone? On the ground. How much time's passed? Nothing. Okay, right here. Where's the drone? 100 and change feet up, right? And that took 2 minutes. That's a long time, right? Drone could be 100 feet up in like 10 seconds, 5 seconds, depending on your drone, right? And it's going up, and it's technically going up forever. Does the drone go up forever? No, because eventually you lose contact with your, whatever, what do they call the thing? Control deck? Is that okay? With the control deck, eventually you lose, right? You can't fly it like to Boulder, right? Because you'll lose contact. But military can fly it for a long time, right? So it depends on the drone. So function not defined for x is less than 0. So we got to write some info here. So function not defined for x is less than 0. So why? Unless you're in a parallel universe, drone can't fly for negative time. Okay? As x goes to infinity,
What's the word after fly?
negative. I just abbreviating. As x goes to infinity, what's f of x do? Also infinity. So the drone's expected to fly higher and higher, but in real life, that's not a thing, right? Because you'll lose contact with your, what do they call it? Control deck. I was going to say flight deck. So not true in real life, right? See, I never knew what that was called before. Now I know. You taught me something. Good job. I like when I learn from students. It's good. Okay, so your homework, we're already done. Homework is page 27. 2 through 10 even. 13, 14, 15, 30, 34.